Okay, so we have the very last problem, and let's read it. One holiday, I gave each of my 3 grandsons X coins and each of my 4 granddaughters Y coins. The total number of coins that I gave to my grandchildren will allow only one ordered pair of positive integers. At most, how many coins did I give to my 7 grandchildren? Okay. How many coins is the ultimate question, and from the 7 grandchildren. Well, let's set up the equation. Since we know that each grandson got X coins and each granddaughter got Y coins, we know the total number of coins is 3x plus 4y. So if I have something like, say both, I gave 7 total. So say the grandpa gave 1 like that. So each boy's got 1, each girl's got 1. Then I have total of 7, right? Okay, and that will be the only ordered pair. And I would like to know that gives only one solution, one ordered pair. Okay, to do that, I can try a few more. So say I have, for the easiest example, I can have 1, 1, which I did, and then 2, 1. So say I get 2 to boys, the grandsons, and 1 to each girl. Okay, then I get total of 2 times 3, 6, plus 4, you get 10. And this is what they're talking about, this X and Y being the only solution, meaning this order pair being the only solution. And just looking at this, it looks like there's infinite number of coins, right? I mean, let's try this first. 3 times 3, you get 9. 9 plus 4, you get 13, and on. It seems like you can have infinite number of total coins. And you might ask, shouldn't they be like the minimum coins? Or maybe you might think the question is typo, but it's not a typo. Okay, this should be 16. Alright, so here's a good example. When I have 5 and 1, I have 19. Okay, but notice, if I have total of 19, I said the solution is only one order pair. But look, I can have 4, actually 1 4. I'll show you why I show you, okay, sorry. I will show you how 1 4 is possible. What I mean is, when I plug 1 into our X, right, I get 3. 4 into Y, I get 16. That's also a total of 19. Meaning we have two solutions. Either 5 one order pair, another being the 1 and 4. This is violation of our question. Only one order pair. Okay. Now I'm gonna show you how this can be done. So visually, okay, I can have 1, so say I gave 4 coins. Let me just make one more. So this is grandson 1, 2, and 3. Okay, he has this many because I gave him so. Each have, say, 5, and they have to have the same number because that's what X stands for. we can have two different x. And for our y, say the granddaughters got something like this. I'll have one more. So that's the first granddaughter, second and third and fourth. And this is the first one has this many, and so on. Okay, you cannot create or lose the total because that's very setup number. If I wanna transfer this one blue, okay, I can't do that. I have 4 here, then I have 5, right? And you might say, what about 3? And you might think it might work, right? Because if each boys lose 1 and they give it to girls, the granddaughters, the problem is, okay, the X has 4 each, right? After that, after losing their one coin, right? Well, here's the problem. Oops. If they sacrifice 1 and give it to granddaughters, we have 5 points for first, second, and third granddaughter. The fourth one only still have 4, and that violates the our function y. Okay, so this doesn't work. Then how can we satisfy multiple solution? Well, 1, 2, 3. Okay. If you look at the common denominator of 3 and 4, or common multiple, least common multiple, you get 12 here. Okay, both are, they cannot be divisible, so 12. Meaning, if I take 12 coins here, okay, 4, 4, 4, 12, now I can distribute that and say now the boys only end up 1 each. See, I did not change my total. Now the boys have only 1 each, right? X equals 1. Now the girls, the granddaughters, have 7 each. Okay. Now that's function because we're not conflicting with the other y, just like before. So, having said that, when we have multiples of 12, we can transfer without changing our t here. How can I write that? First erase this. So how can I write that? Okay, I just explained that they can gain 12. Okay, let me write it first. So I was illustrating this second part, okay, for what I was talking about. I take out 12 from boys and I give it to girls, and X and Y are not conflicted. Or I can do the opposite. I can give 12 from these girls, so 3 each, and then give it to boys. Okay. If you do so, our total doesn't change. I still have 3x and 4y. But if I'm to write this in the factor form, I have 3x plus 4, and then 4y minus 3. Or I can also have 3x minus 4 plus 4y plus 3. Okay. Now you can have as many as 3 order solution, 3 order pair, or 2 order pair. But we need to have only 1, just like you saw in here. But we want to see what's the maximum we can attain. Okay, let me illustrate how to get 3 order solution. That is, if both x and y, so if both x and y in our newly made equations happen to be greater than 4 for x and 3 for y, I'm gonna have 3 order solution. So to illustrate that, Let's see, what kind of example did I use? Okay, I chose very simple one, the x equals 5 and y equals 4. If I plug it in, okay, that's 1, right? For our total, I can have total of 31. How did I get that? 5 times 3 and 4 times 4, 15 plus 16, I get 31. Okay, that's one order solution, one ordered pair solution. No, one pair. Anyway, that's one xy. Okay, I'm gonna plug this straight into our equation. So if I put 5 up here, 3 times 9, and then if I put 4 here, 4 minus 3, I get 1. 1 times 4. (27) plus 4, I still get 31. So that's saying, you know, that 9 and 1 you see can be also our solution. What if we plug it into the second equation in here? So if I plug here 5, I get 1. If I plug 4 here, 5 and 4 here, I get 7. Meaning if I have, meaning I'll have a pair of 1, 7 coordinate. So 3 times 1 and then 4 times 7, well, it's still 31. So in other words, I have 3 set of solutions. The question didn't want that, so this is why it fails. I don't know what's going on. Okay. So this is why this failed. Okay. This was just demonstrating. Okay. Now here's, originally I was thinking of also making it 2 solutions, but you know, I don't want the video to be too long, so let me just explain to you instead of writing everything. So if I have, so for example, here's a way to get 2 order solution. So you just know something like, you know, 5, 4 was, you know, default order, right? So if I have something like 3 and 4, no, actually that would be the answer. No, actually I can try 3 and 4. Here's a problem for our second, this equation, the one you see in the second one, doesn't work because when you have 3 minus 4, you have negative 1. That's not the positive pair. Positive. The question said positive order pair, so that's not positive, so it doesn't work. However, it works for the first one. When you plug the x equals 3, you get 7 times 3, you get 21, plus 4 minus 3, okay, you get 21 here, and then 4 minus 3, you get 1 times 4, you get 25, right? And we still get 25 using this coordinate. So 3 times 3, and then 4 times 4, 16 plus 9, you get 25. That's like saying, okay, because I know that the third one doesn't work, we only have now the 7 and 1. Okay, so this also fail. We have 2 order solutions, we only want 1. So to satisfy that, there's only one choice, meaning to fail both equations, let's set x equals 4 and y equals 3. And we won't have the positive order pair when you set, so let me write it in. Okay, when you set x equals 4 and y equals 3, both will fail. Okay, and this is the maximum you can get. You can try other numbers, but again, if once you go over 4 and once you go for the x and once you go over y, you just fail the one order solution. Okay, moving on. So the t, 3 times 4 plus, no, yeah, and then 4 times 3. So you have 12 plus 12. Our answer is 24. Okay. This is the maximum coins that grandpa could have given to 7 grandchildren. And that's it.